Okay, guys, first video for chapter 23. So you're going to notice that chapter 23, the very beginning of chapter 23, is going to look a lot like your chapter 21. So at this point, we are done with inferencing about a single mean. So now we're going to take a look at comparing two means. Pretty sure I'm just going to skip talking about that. Okay, so the sampling distribution of a sample mean has the following properties, and we should be pretty aware of this at this point. So the shape is approximately normal if the population distribution is normal, or if your sample size is greater than or equal to 30. The center is going to be equal to mu, and the spread, your standard deviation, is now the standard deviation over the square root of the sample size. So if you take a look at these three, so the first one is the distribution of one sample mean. The second one is a distribution of another sample mean. And the last one is a distribution of the difference between them. So you would notice that they are all, the shape is all normal. Your everything is centered at its mean, and so the mean here is 0.07. So everything is centered at the mean, centered at the mean, centered at the mean. Okay, and then your spread. So what we're going to do is use the difference of your means to find the center, and you're going to use the difference of your sum of your standard deviations for your standard deviation. Okay, so that's just what this page says right here. So for the mean or the center of the difference between two sample means will just be the difference between them. But the standard deviation, because we know we have to actually add variances to find your standard deviation, it's never actually subtraction. So this is basically just telling you what we just summed up. And this would be your what your distribution would look like. So you're centered down here. And the distance between, you're using your standard deviation as follows. Okay, so I just have to fill in here because it was not copying straightforward. So in choosing an SRS of size N1 from a population 1 with mean mu1 and standard deviation of sigma 1 and independent SRS of size N2 from a population 2 with mean 2 and standard deviation of sigma 2. Okay. The shape, when the population distributions are normal, the sampling distributions of the difference between the means is also going to be normal. In other cases, the sampling distribution of the difference between them will be approximately normal if the sample sizes are large enough, and we use the rule of thumb about 30. The center of your sample is going to be the difference between their means. And then the spread is going to be notated a little bit differently. The nice thing about this is actually on your reference page. So you don't have to remember it, you just have to know how to use your reference page. Okay. So we're going to take a look real quick at this example and be done with this first video. So a fast food restaurant uses an automated filling machine to pour its soft drinks. The machine has different settings for small, medium, and large drink cups. According to the machine's manufacturer, when the large setting is chosen, the amount of liquid L dispensed by the machine follows a normal distribution with mean 27 ounces and standard deviation 0.8. When the medium setting is chosen, the amount of liquid M dispensed follows a normal distribution with mean 17 ounces and standard deviation 0.5 ounces. To test the manufacturer's claim, the restaurant manager measures the amount of liquid in each of 20 cups filled with the large setting and 25 cups filled with the medium setting. Let the following be the difference in the sample mean amount of liquid under the two settings. So what is the shape of the distribution and why? Okay. Well, because both distributions are normal, then we know that the sampling distribution of the difference between them is also going to be normal. Okay, we're going to find the mean now. So the mean is just going to be found by taking the difference of the means. So 27 minus the 17 is going to be 10 ounces for the difference. So this is and then the standard deviation requires a little bit more work than the means. Okay. So standard deviation of the medium was 0.8. There's 20 cups. And that was for the large, for the medium, and there was 25 of those, okay? And this is going to get you a standard deviation of 0.205 ounces. And that's it for video one, and video one is just a background as to why we can use this and more specifically where this is coming from.